Hey, you guys, welcome to your lesson 1.10. This is function notation and evaluating functions. So far we've seen a function f of a variable x represented by f of x. We've graphed f of x and learned that its range is dependent on its domain, but can a function be applied to expressions other than x? What would it mean if we wrote f of 2x or f of x plus 1? In this lesson, we're going to explore function notation and the versatility of functions. For example, what that means, we're going to let f be a function with the domain 1, 2, and 3. And remember, domain are x values. And we're going to let f of x equal 2x. So to evaluate f over the domain 1, 2, and 3, we would write the following equations by substituting each value in the domain for x. So if we are looking at domains 1, 2, and 3, basically anywhere you see an x. So let me get my pen tool, handy dandy pen tool. Right there's an x and right there's an x. So we would plug each of these numbers, 1, 2, and 3 in each time we see x. So that's what's happening here. So f of x, we plug in number 1 there and number 1 there. So we don't do any on this left side. You don't do any multiplication there. The right side is where you're doing your simplifying. So what's 2 times 1? 2. On the second one, we're plugging in the number 2. What's 2 times 2? 4. The third one, we're plugging in the number 3. 2 times 3, 6. So what we just did is figure out the range. 2, 4, and 6 is the range of f of x. Very, very, very simple math. You just need to make sure you're understanding the terms. So these are new vocabulary terms. It's like a new language, and you need to study what these words mean, or else this won't make sense and you won't be successful. And we want you guys to have a really good math experience. So it starts with really understanding what's the domain, what is the range, remembering domains are x's, ranges are y's, okay? Key concepts: functions can be evaluated at values and variables. To evaluate a function, substitute the values for the domain for the occurrences of x. That's what we just did in the last example. So to evaluate f of 2 in f of x equals x plus 1, you would replace all x's with 2. And you would simplify. So there was an x here and an x here. So we put a number 2 right here and a number 2 right here. So f of 2 equals 2 plus 1. 2 plus 1 is 3. So f of 2 equals 3. This looks confusing. It just says x comma f of x. Remember, f of x is y. So it's the same thing as just saying x comma y, your ordered pair. What we're doing here, these are all ordered pairs. And then those ordered pairs are going to become a function. They're going to become a graph. And if it passes the vertical line test, then it's a function. If it doesn't, then it's not. Okay, common errors and misconceptions. This is a big one. Thinking function notation means f times x instead of f of x because it's written f parentheses x. There is no distributing happening here. There's no multiplying, even though you have parentheses. You only multiply when you have parentheses if you've got two numbers. We don't have numbers here. We have f and a parenthesis and then an x. Again, trying to multiply the left side of the function notation, do not do that. You're just plugging in and simplifying. So let's practice. Evaluate f of x equals 4x minus 7. Okay, over the domain. Remember, domains are x values. What is the range? Range are y values. We're going to take the domain 1, 2, 3, and 4, and we're going to do this 4 times. We're going to simplify. So let's do the first one. So let's do number. We're going to evaluate f of 1. Everywhere we see an x, we're going to plug in number 1. And we're going to say 4 times 1 is 4. Minus 7. 4 minus 7 equals negative 3. Remember your integer rules for when you subtract. Keep, flip, change. Keep, flip, change. So that tells you, because your bigger number is negative, your answer is going to be negative. How many times bigger is the number 7 from 4? 3. and it's -3. All right, let's do f of 2. So everywhere we see an x, we're going to plug in the number 2. Remember, there is no multiplication on this side. That's supposed to be an exclamation point. So we've got 2 here. 4 times 2 is 8. 8 minus 7 equals 1. So f of 2 equals 1. Okay, next we've got the number 3. Everywhere we see an x, we're going to plug in the number 3. 4 times 3 is 12. 12 minus 7 is 5. F of 3 is 5. 4, everywhere you see an x, you're going to plug in the number 4. So f of 4 equals 16 minus 7 equals 9. So the range are the numbers we just found, -3, 1, 5, and 9. Those are the outputs. The inputs, domain. Output, range. Yeah. Example 3, we're going to do example 2 in class. Raven started an online petition calling for more vegan options in the school cafeteria. So far, the number of signatures has doubled every day. She started with 32 signatures on the first day. Raven's petition can be modeled by the function f of x equals 32 times 2 to the x power. Evaluate f of 3 and interpret the results in the terms of the petition. So this looks scary, it looks crazy, but we're not doing anything different than what we just did in the last examples. So here's our original function. We're substituting 3 anywhere we see x. So right here and as an exponent. Now remember your PEMDAS, order of operations rules. Parentheses, we have a parenthesis, just the number 2 is in it. So there's nothing to actually do inside the parentheses. So we're going to move down to exponent. We have an exponent, so that's the next thing we do. So we need to say 2 to the 3rd power. 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. That's where this number 8 comes from. So now we do our multiplication. 32 times 8 is 256. So f of 3 is 256. What that means is on day 3, the petition had 256 signatures. So this is a point on the graph. Remember, domain is x, range is y. Domain is 3, x is 256. If you saw it like that in a table, you would know to graph it. So let's look and see what that looks like. If we actually had graphed all the other days, you would see that at 256 days, at 3 days, there are 256 signatures. So that is a point on the graph. And we will do the other examples in class. You guys, I hope you have a beautiful rest of your day or night or afternoon. And please jot down any questions you have and keep studying these new terms because it will make all the difference.